Welcome back to the Organic Chemistry Reaction App devlog. In the last devlog, I talked about the front end of the app, where basically you have a menu screen that guides you into the puzzle screen, where you solve a puzzle and then get fed another puzzle and another one, and over again until you're done. That's basically how the app is supposed to be used. I also talked about the back end of the app, which I said consisted of 3 different systems: puzzle selection, puzzle drawing, and puzzle solving. I didn't cover these in detail and said I would talk about them more later on. So this time I'm going to talk about the puzzle selection system. I'm storing puzzle information as XML data. The data basically has a puzzle element, which has step elements, and there's going to be 2 steps per puzzle, but there could be more. Each step has molecule elements, at least 1 per step, but could be up to 4. And then finally, each molecule will have various property elements. There are many different properties, so the tag isn't literally property. That's going to be covered more on the next slide, right here. The properties are basically something called smiles. I'll get back to that one. And then there's also information related to the solution for the puzzle. So start values and end values that indicate where you're supposed to start drawing an arrow and where that arrow is supposed to point to in order to solve the puzzle. Hydrogen atoms are kind of tag-along atoms, so their start and end values are stored as properties of the atoms that they're tagging along with. That might make a bit more sense later. I don't know. Smiles. SMILES notation stands for Simplified Molecular Input Line Entry System. This is something that chemists made as a simple way to represent molecules as a string of characters, which is very useful for chemistry software. I didn't invent SMILES notation. It's probably been developed by a large community of computational chemists, but it is a very convenient, ready-made system, and so I'm using it as best I can for my app as well. Basically, smiles are a bunch of letters that represent atoms, and then the atoms are assumed to be bonded together with single bonds. So in this first example, there's CCCO, which is 3 carbons followed by an oxygen. And so the structural representation of that smiles notation is on the right. And the structure of that is N-propanol. You'll also notice that the hydrogen atoms for this molecule are not included in the smiles. They're just assumed to be there. Like I mentioned, they're kind of tag-alongs with the other elements. Smiles can get more complicated, like you can use brackets to denote branching. So if you put the O in parentheses, then you get isopropanol instead of N-propanol. If you want a double bond instead of a single bond, then you can put in an equal sign, and then instead of isopropanol, you get acetone. Smiles can do rings too. It uses numbers for that. But basically, smiles can let you represent any molecular structure as a string of text. Like in this last example, that's vitamin B1, aka thiamine. It's a pretty complicated molecule, but smiles notation is capable of converting that structure into a string of text, even if it's a little bit more of a complicated string of text as well. But complicated molecule, complicated text. It's par for the course. Back to my stuff now. So on the left, I have some XML data from one of the puzzles in my game. You can see there's a molecule, and it's got some smiles properties, start values, end values, H end, and H bond start values. So the game is basically going to take this XML data and parse it into units, which are atoms or bond, and then these units will get stored in an array, which is shown on the right. So the game will also parse the puzzle values into the array. So for this first molecule in the array, you've got C, bond, C, bond, C, double bond, C, bond, C, bond, C. Right? And then start values, it's all zeros except for 1 at the start value, so that double bond will have a start value of 1 when it gets drawn into the puzzle. So in the actual game, it will look like this. You'll have your molecules spawned, and the double bond will be spawned in with the start value of 1. Likewise, the bromine atom, which is represented by the smiles on the bottom left, that will be spawned in, and it will have an H end value of 1, which means that the arrow needs to be drawn from the double bond, which has a start value of 1, to the hydrogen atom, which will then have an end value of 1 as well. The bromine also has an H-bond start value of 2 and an end value of 2. So then the arrow needs to be drawn from the hydrogen bond between the bromine and that hydrogen to the bromine atom itself. So you can see the arrows drawn on the right, which shows the correct solution to this step of this puzzle. So yeah, I guess overall there are 4 main actors in the puzzle selection system. First, there's the XML data, which is stored in a database that the app can access. And then there's the puzzle data array. The array is basically the same thing as the XML data, but it's like, I don't know what the right word for this is. Maybe active data. It's taking the data out of the database and then storing it temporarily somewhere that is more accessible for the app to use. There's faster loading times. That's what the puzzle data array does. The puzzle data array is a 3D array where one dimension is a step value. So right now I have up to, I think, 11 different steps plus an extra like holder step. So it goes from 0 to 11. And then there's another dimension of the array is the molecule step, which there's 4 different molecules, so 0 to 3. And then the last one is the properties strings. And I think I have 12 properties right now, so it goes from 0 to 11. The third actor is the parsing system. And the parsing system takes the strings that are in the puzzle data array. So the properties in the puzzle data array are strings of characters that need to be parsed into individual units. So that's what the parsing array does. So like, for example, this one smiles here. It'll split the smiles up into individual units, like an O+ unit, some C's, some bonds, some brackets, and a BR. Note that some units consist of multiple characters, so it's not as simply as just cutting up a string character by character. You have to look at what the characters actually are and how they fit to create individual units. But anyway, the parsing system will then, it takes the smile strings from the puzzle data array, parse them up into units, and then it stores them in the step data array. So the step data array is the end of the puzzle system. Basically, it has all of the results of the parsing system, and it will have, it's another 3D array that has molecules as one dimension, properties as a second dimension, and then the value, which are the individual units from the string, as the third dimension, I guess. But yeah, so the step data array is the end of this puzzle selection system, and it's kind of the start of the puzzle drawing system. The puzzle drawing system will read this array to start drawing the puzzle. So that, I guess, ends this devlog, but I guess we can go back to this one. So this array shown on the right here is a 2D cross-section of what the step data array will look like. And then that gets drawn, and we'll get to that. So maybe I'll go over the puzzle drawing system in the next devlog to make more sense of it. But yeah, for now, we'll go up to update 1.0.1.5. This update adds some new puzzles like usual. That's going to be a common theme. Got to get more puzzles in there. It also readjusts how puzzles are loaded for fully randomized puzzles and for user-selected puzzles. This wasn't working last time. I tried to fix it. It wasn't working, this time, so I'm trying to fix it again. I don't think I fixed it with this update, but I'll keep monitoring it and we'll see what happens. The other thing this adds is directional bonds, wedges and dashes, for example. Wedges and dashes are used to depict three-dimensional structures of molecules. So molecules are, of course, 3D objects in the real world, but when they're represented on a screen, they're represented in 2D. So you can use wedges and dashes to indicate that a molecule is sort of going up and out of the plane, or you can use a dash to show that it's going down and sort of into the plane of the drawing. This is something that chemists do, and it might be useful for some puzzles, so I've implemented it here. Beyond that, there's some minor bug fixes, so yeah. If you haven't tried the app yet, then why not try it out on your Android device? Give it a download. Let me know how it goes. But yeah, for now, thanks for watching, and I hope to see you next time.